Before moving to AWS, one of your questions will probably be, do you have a security system? Amazon will answer, yes, we have Identity and Access Management, a web-based service that secures everything at AWS. Identity and Access Management is designed to control access. You want to design your access based on least privilege, giving the least amount of privileges to your administrators so they can do their job. Not all of the privileges, because then they may get into trouble. Identity and Access Management is controlling access to all AWS resources. And it's required by most security and compliance standards these days, whether it's HIPAA or NIST or ITAR, FedRAMP or ISO. They all have their own demands. They all have their own requirements. And third-party audits reaffirm that their mandated security controls and requirements are in place and are functional. And you can log on and look at these reports and reaffirm that you're okay with working at AWS. IAM is security policy, policies for the authentication of IAM users, policy for groups of IAM users after they've authenticated. Remember, we can only authenticate as a user. IAM is going to control the authentication of known users and then control the authorized access to the Amazon resources that you want to control. The major component with IAM is security policies. These policies can be something that you create from scratch. Most likely, you'll start off by using one of the managed policies. Managed policies are numerous. Amazon has created hundreds of managed policies that you merely have to attach to a user account or to a group account or to both. You can also take a managed policy and copy it and then create a custom security policy that's slightly different than the default managed policy. Security policies can also be deployed in something called a role. Roles are assigned to externally authenticating users, such as somebody that is logged on to Active Directory at work. Then let's say that user has to access resources at AWS. Their Active Directory credentials, the on-prem credentials, are synchronized with a copy at AWS. This is recognized as a valid user account, and therefore the user will be assigned a role providing temporary access to the resource that they need to access. Each AWS account has a couple of unique IDs. One is the account ID, a 12-digit number, and one is the canonical ID, a much longer string of numbers. And you can gather this information. You can actually do a download of all of the credentials and all of the information for your AWS accounts within IAM. The IDs themselves are displayed in the properties of the user account as the account identifier. We use names, computers use numbers. If I'm accessing a resource at AWS, I'm going to have to fire off an API call. That API call will only be successful if it is associated with an active access key. And every IAM user has an access key ID and potentially a secret access key. The default after creation is that the access key for a particular user, they're active, which means you could turn that off and say they're not active. If a secret access key is lost, a new key can be created. Secret access keys are used, for example, for scripting, for carrying out processes at the command prompt. And the secret access key and the user ID would have to be identified and associated with that script in order for that script to run. If you're using Amazon with multiple accounts, this might be kind of useful for the organization of users within your organization. You might want to break down the accounts into development, into test, into production. You might want to separate accounts for specific needs of your organizations, for security requirements, for location requirements. Now we're talking about multiple IAM accounts. We also may have multiple AWS accounts. What we're talking about here is multiple accounts, multiple IAM accounts within a single AWS account. So we can create users and groups much like we would do on-prem to manage our resources at AWS the way we want to. We can also define cross-account access. Now, this is defining access between multiple AWS accounts. So if I am an IAM user in one AWS account, let's say account 123, and I want to access resources in another AWS account, say 456, I can have a role assigned to me that gives me temporary access to specific resources in another AWS account. Now, the creation of the roles is an administrative task that has to be manually enabled and set up. If I need access to the management console, if that's all I need when I'm creating IAM users, well, then I'll assign a password. And I won't create for that user a secret access key. If you need access to AWS resources with scripts or automation, there's an account. When I create an IAM user account, I'll also create a secret access key. For controlling access to AWS resources, I'll attach security policy to a particular user or to a particular group of users. For best practice, I should add users, even if it's a single user carrying out a specific task, to an IAM group. The odds are a second or third member of your company will need to carry out that specific task. Adding that new IAM user to an existing IAM group allows you to assign permissions easily and effectively. For extra security requirements, enable multi-factor authentication at the properties of each IAM account.